so we are doing the second tutorial, which is on aggregates. Okay, so that is your second topic. So there are 4 questions again. We'll start with we have just 1 hour, so I won't be able to explain you the theory. However, whatever the theory needed for you to do the questions, I will explain while we are doing the questions. Okay, so it's a whole lot of theory. If you look at your lecture 2, there are so many things that you need to learn. So you can, after doing the questions, you can go back home and read everything because they are very important. And also you have MCQ questions in your quizzes and also in the final exam. So everything is needed. Just knowing how to do the calculations is not enough. Okay, so this one is a very easy question which you can do even without knowing anything about the aggregate. So here they are saying determine the total moisture content for a sample of sand that has a wet mass of 625.2 grams and the oven dried mass of 589.9 grams. So total moisture as a percentage, if you want to find the moisture content as a percentage, what do we mean by the moisture content as a percentage? Amount of water, the mass of water divided by the mass of the dry aggregate, and you times by the 100%, then you will get it as a percentage. Can I give you a few minutes for you to try this one? What did you get for this one?
5.984.
Yes, that's right, or roughly 6%, isn't it? So the amount of water we get 35.3 grams, and if you make it to a percentage, that will be roughly about 6%. Do we all get that number? Any question? No questions? Okay, then we'll move to the second question. And this one is easy, but the second question is very important. It is long and it is important for us as well. Okay, so in the second, we need to first understand the question. So they are saying a table below shows the sieve. So I will show you the table later. So there are four aggregates. So these are the aggregates which are available in the market. So A, B, C, and D. So and these aggregates have different particle size distributions. I'll show you the table in a minute. So they are asking us to plot the aggregate grading percentage passing in a graph. Okay, so first question is for us to plot the percentage passing in the grading graph. And in the second part of the question, they are saying we need to have aggregates for a project which should be AC20 and AC28. So these AC20 and AC28 are again with the particular particle size distribution for our project, and they are asking us to plot that one as well. Okay, so let's do that part first, and then we'll move to this one later. Okay, so I'm going to show you the tables. Do you guys have the graph paper? No. Okay, I'll explain you. This is your homework. You need to do it at home. Okay, so this is the grading graph, and if you look at the grading graph, you have percentage passing in your y-axis, and in the x-axis we have sieve sizes. X-axis is a log graph, so this is a semi-log graph. You can plot the graphs in Excel as well, but you need to remember that x-axis you need to make it to a log scale. Okay, so if you know percentage passing and if you know the sieve sizes, so here we have sieve sizes 37.5 millimeters, 50 millimeters, 25 millimeters, 19 millimeters. Likewise, if you know the sieve size and the percentage passing, we will be able to figure out and we can plot it. For example, if we say in this size percentage passing is 100%, we know where to plot it. If we know 19%, 65%, so this is 60, 65 is here, and 12.5, maybe 40%. Likewise, we can plot a graph like this with the particle size distribution if we know the percentage passing and the sieve size. Do you agree with that? Any question? So if you look at the table that they have given to us, so you can see those information is available here. So sieve size is given to us. So sieve size is which which X or the Y in our graph? Sieve sizes was in the X-axis, am I right? And the percentage passing, these numbers were in the Y-axis. So if we know the Y-axis and the X-axis data, we will be able to plot the graph. So you have to, as you don't have your graph paper today, you need to do this at home. Okay? And are we all okay with plotting this A, B, C, D? Any question? Now we have this grading envelope as well, AC20 and AC28. How do we plot these two? They have a range. So how we plot that one? How we plot the AC20 and AC20? We call it an envelope. When you are plotting that, you have a minimum value and a maximum value. So you get two lines here. Okay, so you need to plot that one as well in the same graph. Everything is plotting on the same graph. So you can see an envelope like that. So for both the AC20 one envelope and AC28 another envelope. So you will see two envelopes and four curves on the same graph. Are we good? So that's your homework. Okay, now tell me, they are asking us to find our project. In our project, we need this AC20 and AC28. Can you check these numbers and tell me, for AC20, can we use either A, B, C or D for AC20? Are they satisfying the percentage passing? No, why is that? So this 100 is okay. A okay, B, C, D all okay with the first one. How about the second one? It should be between, this one is not okay, but these ones are okay, isn't it? So likewise, can you check and let me know whether we have any of them? Like, if you look at this, 58 to 75. So this one is already gone. And if you look at this, this one is okay. Am I right? These two are not okay. So these two are also gone. So B, 35, 30. So this is also gone again. It is not between 37 and 55, isn't it? So we can't use A, B, C, D, separate any of them as they are for AC20. Agree or not? Can you check the AC28 as well and tell me whether any of those are okay with AC28? None of them. So what we need to do? What we should do? We need to blend them, and it is a trial and error method. So we are going to blend them, and we are going to find something which is within envelope. So we need to find one blend for this one and another blend for this one. So they have given us in the question to start with these percentages. So we take 30% from A, 40% from B, 20% from C and 10% from D, and we are going to blend it together, and we are going to find out whether that blend is satisfying any of these ones, AC20 or AC28. Even when you plot these graphs, you can see AC20 is an envelope like that. You don't see any of these are within the envelope. So you don't see this one lie inside the envelope because they are out. They all are out. So you need to get something which is within that envelope, goes in between the two lines of the envelope. Make sense? So we are going to blend them in these proportions, and we are going to find out whether that blend is okay or not. So how do we blend them together? Blended. So these are the graphs actually when I plotted it like that, but you guys can plot it in Excel. So envelope should look like this, and when you find the right trial, that will stay in between the envelope. So envelope is the black line and the blue line is something within the envelopes. Okay. Now we are going to blend them in these percentages, 30%, 40%, 20% and 10%. Blend it. We can find the particle size distribution of the blend, and you calculate it like this: 30% from A, 40% from B, 20% from C, 10% from D. So will you be able to calculate me few of these ones, and I will give you the rest of the numbers, but I want to see whether you have understood how to do this calculation.
The first one's going to be 100%.
First one is anyway 100%, yes. So second one, how do we calculate it? 30% from 65. Yes, that's right. Yes. So calculate few of them, please. And the next one will be 40% from 100. Do you guys understand it or not?
Yeah.
Okay, so I'll give you a few minutes for you to do that, and I want all of you to do the work in the class. Otherwise, I won't be able to, give you the marks for the attendance. I'll give you time.
No, like the answer of the whole thing? Yeah.
Did you get these numbers? Did you get these numbers at least the first few numbers? Is there anyone who didn't get these numbers? Or getting the numbers? Okay, so what can you say about this? By looking at these numbers, what can you say? Is this blend okay with AC20? Why you are saying no? Yes, so all are okay except this one, am I right? Is that right? All okay except this. So 89.5 is not within 90 and 100, and also it's not within 73 and 80. So this blend is not okay with either AC20 or with AC28. Agree or not?
Yeah.
Okay, so what we need to do, but we can take this as a base for finding out which one to be increased, which one to be decreased. Okay, so let's forget about the AC28. Let's do the AC20. Tell me, we need to bring this number down. 89.5 should be above 90, isn't it? So we need to bring this number up, increase it. So which one need to be? If you look at A, B, C, D, if I increase A, what will happen? That number go further down, isn't it? So we need to decrease A and we can increase either B, C or D. Agree?
Yeah.
What can you say about the AC28? So we need to bring this number down. Am I right? So to bring this number down, which one need to be increased? We need to increase A. So we need to decrease A to get the AC20, and we need to increase A to get the AC28.
So
do you agree?
A and then we decrease the rest of them?
If we increase one, it should be 100%. If this proportion should be 100%. If we increase A, we need to decrease any of those. Do you agree or not? Okay, so I'm taking 30% from A, 40% from B, 20% from C, and 10% from D. If I want to decrease this one, if I want to decrease this one, maybe if I want to make it to 35%, I need to change, I need to add an, I need to minus 5% from, otherwise I don't get 100% here, isn't it? If I increase this to 35, I should decrease one of these by 5%.
So just one of them?
One of them, or else you can split 2.5, 2.5. It's up to you, as long as you get 100% at the end. Make sense? Okay. So, are we good up to here? Any question? So we need to increase and decrease. We need to increase the 89.5 for AC20 to okay, so we are going to look at AC20 now. Okay, so to find for getting AC20, we already discussed that we need to bring the A down. So what I have done is I have decreased this to 25 and I have increased 5% the C. So now again, if you look at these numbers, we still get 100%. It's up to you to decide which one to increase. Okay, but we definitely need to increase decrease A, because we need to make that number higher, but it's up to you to decide either B, C or D, which one to be increased. Okay, it's a trial and error method, and also you don't have to increase 5%. You can do 2.5, 2.5 or 2. It's a trial. You may go wrong, and we can do the third trial then. Can you find the particle size distribution for this new blend? This is our trial 2. Can you find for few numbers? Okay. Okay, so let me see. Do you get these numbers? At least first few numbers. Did you get these numbers? We just changed by 5% because it's a small number. We need to increase a little bit. Did you get these numbers with the so you need to do it for all the sieve sizes, okay? Not just one. When you are blending it, all are changing. So now, what can you say about the new blend? What can you say about the new blend? Do you have a question? What was the problem?
How did you come up with 25 for the new blend?
What's that?
How did you come up with 25 for the new blend?
Okay, so in the previous one we had 30, 40, 20 and 10. That was our trial. We just started with a random number, like the trial numbers. Then we got this blend, the percentage passing for the trial, but the 19 sieve size was not okay. And we wanted to increase that number for the 19 sieve. To increase it, we need to decrease A. Do you understand why we are decreasing A? If we decrease A by 5%, we need to increase another one by 5% because altogether it should be 100%. So we are decreasing A by 5% and we can increase either B, C or D.
So you've got 30 to 25 and 20 up by 25%.
Yes, A dropped by 5% and I increased C by 5%. Then only it will be 100% altogether, isn't it? Are we good? Is this blend okay or not? For AC20? AC20, is this blend okay or not? Yes, it is. So we can use this as our AC20. So when you plot this in your grading graph, where this should be in? It should be within the envelope. It should go inside the envelope. Okay? So you can you can plot this one as well. Any question up to here? Are you guys okay now? Okay. Now we are going to find something for the AC28. What we need to do to find the AC28? Now we need to decrease this 89.5. To decrease this, we need to increase A, and we can decrease any of them, B, C or D. So what I'm going to do is I'm going to increase A by maybe 10% and decrease B by 10%. Can you calculate?
How did you know 10%?
It's like this. In the previous one, we have to decrease by a little amount, like increase by a little amount. This one it's bit more, isn't it? So here we get it's a trial. It's a trial, but you can guess it. If you want to increase a little bit, maybe 5%. If you want to increase a bit more, then 10%. Go like that. You can do it like you don't have to you don't have to use all 4. You can do it with 3 as well. It's just a trial. As long as you get something within the envelope, that should be fine. You can do it maybe 3 or 2, blending 2 together as well. And we have software to do this. And we just learn because we need to learn the theory. Can you find the first few numbers, please? So let me know when you find few numbers, okay? What do we get? Do you get these numbers, at least the first few? What can you say about the blend, this blend? It's okay with AC28, right? When you plot it, it will go within AC28 envelope. Okay, so that's the whole question number 2. So plotting the graphs and getting the right blend. Any question? Any question? Can I move to the next question if you don't have any question regarding this? Okay, question number 3. Aggregates from 3 sources, A, B, and C. Again, we have three types of aggregates having properties shown in the table below, were blended at the ratio of 30%, 30 to 60 to 10. And by weight, determine the properties of the aggregate blend. So we have the angularity of A, B, and C. We don't have to blend them and check the angularity. We can use these numbers and we can calculate the angularity of the blend in the same way that you have done before. So can you please find me the angularity of the blend? 30% from A, 60% from B, and 10% from C. If you do the calculation in the same way that you have done, what do you get? Yes, that's right. So we do the same equation we used before. So like this, isn't it? 30% from A, 60% from B, and 10% from C. So do we all get the same number, 83.6? Okay. How about the other two properties? Other two properties are specific gravity. So whenever you have a specific gravity, it can be bulk specific gravity, apparent specific gravity, or any specific gravity, you are not going to use this equation. Okay, so it's if you use this one, that is not the right one to use. Okay, so you need to remember that when you have specific gravities, you have to use this. You have to calculate it in this way. So here P is the proportion. So proportion means 0.3, 0.6 and 0.1 in this case. If you want to use 30, 60 and 10, you can make the numerator to 100. It's up to you. So if you want to use P1, P2, P3 as 30, 60, 10, you have to make the numerator to 100. And then the G is your property. So G1 is 2.77, G2 is 2.71, and G3 is 2.39. So when you put these numbers in that equation in given in there at the top of the slide, what do you get for the bulk specific gravity of the blend? Even when you use the wrong equation, you will get some value, closer value, but it's the wrong method. Okay, so you don't get marked if you use the wrong equation. So you need to use the right one. So when you use the right one, what do you get? No, not the first one. First one we did with this. We already did this 83.6, isn't it? You have to use the previous equation for that. Yeah. This one, this equation here is only for the specific gravities. Okay, not for anything else. It's for the specific gravities.
2.7.
2.7. Do you get 2.7? What do you get? 2.7? Okay.
2.69.
Okay, yes. So let me check whether what numbers I got. Okay, so these are the numbers. When you have two decimals, keep it to two decimals. Okay. Yeah, so there are other numbers also two decimals. Okay, so are we good? Do you get the same numbers? Okay, so what do you need to remember? Whenever we have a specific gravity, you need to use that green equation. Okay. Any question?
P1 is obviously the first row, J1 is the second row.
No. P is the proportion. It can be 30, 60, 10. P is the proportion. Or if you want to make it a percentage, you have to put 100 at the top. Then you can use P1 as 30, P2 as 60, P3 as 10. If you want to make keep the numerator 1, it should be 0.3, 0.6 and 0.1. And G is the property. Okay, are we good? Can I move to the next question? Do you need more time? Do you guys need more time? All good? Okay, can I move to the next question then? Okay, so this is for us to find the fineness modulus. Okay, estimate the fineness modulus of the sand sample from the following sieve analysis data. So they have given us the sieve size and the weight retained. So in the previous, second question, they have given us a percentage passing. So normally when we do a sieve analysis, we find out the amount retained in each of the sieves. So these are the grams in every sieve, how much of the aggregates are retained in each of the sieve. So we need to convert this to a percentage when you were doing the particle size distribution graph. But for finding the fineness modulus, do you know what is fineness modulus? From the lecture, what do we mean by fineness modulus? What's that? What is it? This is from your lecture notes. What do we mean by fineness modulus? Adding this cumulative percentage of aggregate retained on each of the sieve divided by 100. So if I write it, sum of the cumulative percentage. This we call the fineness modulus. Agree? Do you guys agree with that? So we need to know the percentage weight retained, and you need to take the cumulative value of that, and then you need to add them together, and then you divide that by 100. Am I right? So we need to know the percentage weight retained, then we need to take the cumulative value of that and add all the cumulative values together and divide by 100. That will give you the fineness modulus. Is that right? Okay, so in the table what was given to us, weight retained, isn't it? So we first need to convert the weight retained to a percentage weight retained. So how can we convert a weight retained to a percentage weight retained? Yes, so you find the total amount, total weight. Can I give you a few minutes for you to find the percentage weight retained? Cumulative percentage weight retained over 100, yes. Okay, so this is your table. When you add all the weight retained together, I got 480. And can you find the percentage weight retained? I'll give you time and find the percentage weight retained. So this weight retained is 12. Total mass is 480. So 12 divided by 480 times 100%. So you need to do that for all. and then you can find the cumulative value. Just fill this one, then I will tell you how to do the cumulative. Is just cumulative. So what did you get for these numbers? Did you get this or not? So if you have done this one right, you should get 100% at the end. Okay, so now how do we make it to a cumulative percentage weight retained? So what you do here, this will be 2.5, this will be 2.5 plus 10, the next one will be 2.5 plus 10 plus 20. So you get the cumulative value. Can you find the cumulative value, please? When you find the cumulative value, what do we get? Yes, yes. So do we get these numbers? Now what do we mean by the fineness modulus again? What was the fineness modulus? Sum of the cumulative percentage weight retained divided by 100. So you need to take the sum of this and then divided by 100. Am I right? So the fineness modulus is 2.9. Do you agree with that? So if you look at the equation for the fineness modulus, that should be the sum of the cumulative percentage weight retained divided by 100. So in our case, we get 290 divided by 100, which is 2.9. Is that right? Are we good? Okay, so that's the 4 questions. Do you guys have any other questions? So in that case,